Hello and welcome to AppC Monthly, a DevCentral podcast featuring contributions from Aaron Brailsford.
You know, it is relatively easy to breach an organization because usually soft, flashy things.
Malcolm Heath.
Just from a basic sort of security perspective, it's better to fix things earlier than later. It's better to structure your architecture and stuff that it's in such a way that it's secure rather than trying to build security on at the back end.
David Warburton.
What really fascinates me from a security point of view, now I like to kind of get geeky now about crypto stuff and all the next technologies, but actually so much of security, like probably the most pivotal part of security is trust.
And more. I'm your host, Aubrey King from DevCentral, and we've got a great show for you this month, so strap on those earbuds and get ready for AppC Monthly. Wow, okay. Geez, it's crazy, like a name change, right? And this is the second month in a row that I've had to change the opener for this show. Welcome, community. Sorry, I should have started with that one. I'm your host, Aubrey King, and happy to have you on for yet another edition of AppC Monthly, the artist formerly known as This Month in Security. Yes, we decided to just do a random name change, wanted to get it out there, not so random, right? We wanted to make sure that the podcast is a little bit more searchable, and we really kind of associate ourselves with the audience that is interested in the topics that we cover, right? I mean, we talked about it as a group and kind of thought, well, you know, someone doesn't know if we're going to be having a segment on lock picking or whether we're going to be talking about, you know, DOS settings or what, you know. So this is a little bit more focused, and I hope that everyone can get behind the new name. So we've got a very interesting show this month for you guys, a whole lot of cool stuff that happened in the news. But I'm going to share a couple of segments with you. I've got a lot of teasers because I ended up doing some longer interviews this month with some really cool guests. One that I think everybody who is familiar with DevCentral should know, and that is one Peter Silva, right? So I did catch up with Pete Silva just to find out what he's doing. We're gonna hear a little bit from him at the end of the show, after we hear from our roundtable panelists, which are, you know, our usual group of brainiacs in Aaron, David, and Malcolm. And before that, though, I want to share a conversation that I had with a guy named Jonathan Werrett. If you don't know Jonathan, he is the chief of security over at a company called SemGrep. If you don't know SemGrep, well, you really should. Just Google it, look them up, what they do. If you're somebody who's really concerned about things like, hacked software libraries and things of that nature, if you're, viciously attacking your SBOM goals right now, SemGrep is one of those companies that you might want to pay attention to. So he and I had a chance to just sit down and talk a little bit about how AI changes the game for blue teamers and red teamers. This is a guy who's been in the industry for quite some time and has been on both sides. He's been that blue teamer. He's also been that red teamer and focused on the penetration testing and things like that. So really interesting stuff to hear from a veteran on how AI changes this whole thing. You're going to have to go to DevCentral YouTube. That's youtube.com/DevCentral to find the full video. But in the meantime, I'll give you a couple minutes. It's funny you mentioned how the LLMs are real good at making things that are very human-like. I've sort of theorized that, like, in the future, I think that email will be able to come to a grinding halt at some point out there.
That's a good thing, right?
Is it? Well, it's not so strange to think about, honestly. If you think about it, most service providers keep things at 80%. That's just, the 80-20 rule. It's how you maximize your efficiency at scale. So if you think about that, I feel that, knowing that 99% of all inbound mail is dropped as spam, if all of a sudden every single spammer was able to overwhelm that mail filter, right, you're going to 100x your traffic, which is going to make that 20% disappear. I mean, instantaneously. The volume of mail that's out there is ridiculous. So I digress, but it does kind of get me into the whole red teamer sort of aspect, kind of on the offensive side of things, how do you think AI, I mean, aside from the obvious email example there, how do you think AI changes really kind of the red teamer game out there?
Right. So I think you put your finger on it in terms of like the asymmetry between like red team and blue team. I think, unfortunately, we've got theories about where AI can be useful for blue teamers. Bad actors don't have theories. They've got like some really good working examples right now. It's a lot clearer for them. So a bad actor, they just need to have a success every 1,000 or 1,000,000 sort of instances of whatever they're doing, like particularly email examples like you're talking about. Unfortunately, the blue teamer isn't going to be happy with that sort of like false true positive rate. So the red teamer has it a lot easier. AI is really good at spitting out text, really good now at sounding like, well-written prose. If you particularly go back to that email example, right? Like maybe still you can spot a spammer by their terrible grammar and English, but plug ChatGPT into that, and all of a sudden that is a problem or an indicator that has gone away. So social engineering is definitely the place where we're already seeing a lot of sort of AI or large language model use.
It's one thing to hear about AI from kind of, the perspective that we bring to the table, right? It's people who are talking about artificial intelligence and what that brings to our attackers. But it's a completely different thing when you're hearing it from somebody who is like the blue teamer at a company, right? I mean, that's his job, is to understand what kind of attacks are hitting a newer cybersecurity company, which is a tremendous amount. So I would tell you, go check out the full interview with Jonathan. It's about 15 minutes or so, and it's chock full of fun. Really, we had a blast talking. I really enjoy it when I get a guest on the show who wants to just have fun and not take it so seriously. So that's one of those things that that he and I had a great conversation. Now, another thing that I wanted to show before we get into our roundtable is a bit about, you guessed it, AI, but not maybe what you'd think. There was probably a couple meetings ago at the top 10 for large language model applications meeting, where I had noticed that there was quite a bit of AI washing in product on the news, and wanted to just kind of put something out there to the group. I think it really rang true at the top 10 meeting. Now, I hope it'll be useful for our community here in DevCentral as well. So this is me with a different face on.
Well, that really is what we had to cover today. Is there anything anyone would like to add?
Yeah, I got one.
Okay.
I was just going to bring up something that I've seen a little bit out of some DOS vendors out there in the news. And one thing that I have fought in my own company is this, to try and get an understanding out there of the difference between model DOS and DOSing a model. So if there's nothing else I can say about this point, I guess one of the things that I'm seeing is that a lot of DOS vendors are coming out there and saying, we defend against model DOS as per the OWASP top 10 for LLM apps. But when you're just adjusting rate limiting or, for inbound connections, that is not defending against model DOS at all. It could be where, if you've got a human that is taking a look at the application and saying, boy, my application is messed up, I better adjust my DOS settings to help my application, which happens to be, LLM based. That's one thing, but again, that's not really protecting against model DOS. It's protecting against DOSing a model. And it seems per our docs that there needs to be some sort of communication on what is happening with the model to influence automatic defense in terms of DOS. So I just wanted to kind of put that out there and see if anyone else is kind of has noticed the same thing. Because it is something that I'm trying to make sure that I know my company isn't going out there and speaking incorrectly to say these things. That's right. We have paid careful attention to make sure that we're not making statements about technology that we don't have at this minute, right? Like you can't just put AI in front of a product name and think that you're going to be protecting against the AI version of that thing. It's not the same kind of security measures. And I hope, if nothing else, I just encourage people to maybe question what your vendor is telling you, okay? Because a lot of AI stuff out there right now. If you're not paying attention to the top 10 for large language model apps, you're probably missing half the story. So don't just trust your vendor. Go get the knowledge yourself. And with that, I'm going to give you some knowledge, right? We've got our guys who are going to be coming in and doing the round table. I'm going to take a second and bring them on, and I'm going to get out of your face and let the smart guys do their thing. So enjoy.
Thanks, Aubrey. I disagree that we're the smart guys. I think we're one of them too, but
we proved that point very clearly.
Yeah. So it's myself, Dave, and Malcolm, as we often have, to go through some news from the month. I thought I'd start us off with a strong one, and Palo Alto's recent critical vulnerability, CVE 2024-3400. I think this is, it's known to be exploited in the wild, and it was disclosed quite recently on the 12th of April and fixed on the 14th of April, which I mean is fantastically quick in terms of time to fix from any vendor, and having been on the inside of that kind of thing, I can only imagine and appreciate the work that must have gone into that. But I'm guessing you guys also read about this news.
I did. So I've been reading a little bit, but I was hoping, Aaron, you could kind of explain a little. Why is this one made? Why is this one being such a big deal? Why is it kind of making the headlines, and why is it being such a problem for people? I mean, like I said, Palo Alto have done a fantastic job in responding quickly, but I feel like that was kind of needed because of how rapidly this kind of came to be.
Yeah, so this made the news because it was a 0 day, like a true 0 day. It was discovered already being exploited in the wild by an independent research firm, incident response firm, actually, I think, who discovered that this, so a device had been compromised, and then worked back from there to how it was compromised, and involved Palo Alto's security incident response team in figuring all of that stuff out. But yeah, these things are always big and impactful when it's a 0 day that's known to be exploited. And if you combine 0 day with this is a critical unauthenticated remote code execution, CVSS 10, it's going to make big waves.
Yeah. So who exactly did this affect? Was this every single Palo Alto kind of customer? What products? Was it kind of default configuration, which is obviously one of the worst kind of possible, CVs you can have when you just switch it on, it's immediately vulnerable. But who was actually open to this problem?
Yeah, so it was Palo Alto's Global Protect product. So it's not every Palo Alto product, and also only if you had the optional telemetry features turned on. And I believe they're off by default. So if you turned them on, then you are vulnerable to this particular issue. So yeah, mitigating circumstances, it's probably a relatively small proportion of Palo Alto's customers. But it is also in a VPN product, and everybody gets very nervous and twitchy when there's an RCE in a product that is designed to provide secure access to networks.
Yeah, understandably so. So presumably the kind of the ultimate kind of end goal or potential kind of vector would be, after initial kind of compromise, if it's remote code, you potentially got full-blown network connectivity to anything that device is then connected to. Is that right?
Yeah, and so what the incident response company Velexity discovered was that a threat actor was dropping backdoors onto the Palo Alto boxes, dropping a backdoor, I should say, written in Python. They actually worked back after this had been discovered and found that they found their first backdoor on the 10th, I think, of April. And when they looked back, after they'd presumably everybody had scrambled to do the initial response to this happening, they found exploitation as far back as the 26th of March, and a pattern of exploitation where a threat actor was dropping 0-byte files. So I'm guessing they were touching file, calling touch on a file on the file system to kind of figure out what they could do on 326. And then on the 7th of April is the earliest actual backdoor they found dropped. So that's how long it took the attackers to go from presumably initial discovery to full exploitation. Although I don't know if attackers are typically discovering vulnerabilities on, production systems out on the internet. That seems to have been what happened here. That struck me as unusual.
Yeah. I think that is a little bit unusual. I think I think that's a really, really interesting finding, because I would imagine that probably the more common scenario is somebody actually finds finds a bug, gets it to the point where it's reproducible, where it's useful, and then maybe sells it, right? Or something along those lines. So you have the research essentially being done prior to any exploitation. At least that's my understanding of how at least sort of the commercial access broker market and so forth works. So this is interesting, and I'm really curious now, and I'll have to wait a little while to find out, I'm sure, if there's been any sort of threat actor identification done on who was doing this, like what are their motivations, or who are they, or what sort of things they were accomplishing. And in fact, I haven't seen, maybe you have, Aaron, they were installing backdoors, but what were they doing with them? Were they, going for a ransomware kind of play, or were they, was it more of an espionage kind of angle? I don't know.
Yeah, I haven't heard. Certainly ransomware, which would be the obvious first angle. I think you're right. It struck me as really weird that they were seeing 0-byte files dropped on quite a ways before active exploitation, or rather before any kind of backdoor was dropped. The other reason is because if you're dropping a 0-byte file, that is something we've done discovering stuff in our own environments. But it only helps you if you already have access to see that the 0-byte file was dropped.
Mm-hmm.
So it's kind of weird to be doing that on a production system if you didn't already have some kind of root access to the file system to see your own success. It's a weird test case. I haven't seen what. So the backdoor was dubbed Upstyle, the Python backdoor, and it has a full C2 channel, but I haven't seen much documentation about what the attackers were then using that to do, presumably to pivot into somewhere else in the network, and then what they did after that. Anyway, I'm just doing a little bit of quick reading on the fly. There is a suggestion here that their initial objectives were basically grabbing domain credentials, which that's a logical first step, right, for any kind of pivot into the rest of the network, but nothing on what the attacker was going to do after that. I guess if we do see any kind of breach notifications that then get tied back to this initial access, maybe, like you say, we'll find out in time.
And I mean, as Malcolm suggested, it could be the work of initial access brokers who are literally just selling access to the kind of platforms and systems with no intention themselves to do anything, but literally just selling access to other people's networks.
Yeah, that's entirely possible.
I just want to bring up one quick thing about this too that struck me was this, as you said, was tied to the user telemetry, right? It was an optional feature that was turned on that did telemetry.
Yeah.
that is in my opinion, that is an under-examined vector that I think we're going to probably see more of, because it's kind of perfect. You're by the nature of telemetry, you are parsing untrusted data, and you're probably doing it at a relatively high privilege level, or possibly even shipping it off somewhere else. And without really thinking through exactly how you're going to constrain that data, how you're going to make sure that that data doesn't include things that are malicious or that can trigger bugs in secondary or tertiary systems. I expect, and not to keep harping on this necessarily, but in some ways, Log4j was kind of along the same lines, or Log4Shell, I should say. This kind of general classification of how do we take untrusted user data, not to process necessarily with the direct app, but like we're going to harvest it in some way, and then we're going to do some processing later for the purpose of telemetry or logging or what have you, seems to be a kind of a rich field at the moment for vulnerability research. So,
yeah, Log4j should have been a very cautionary tale.
Yeah, it should have been.
Yeah. Possibly not one we paid enough attention to as an industry, but yeah. So moving on before we run out of time, to another 0 day, actually, that just from at the time of recording yesterday, there have been advisories out by NCSC, so in the UK, and CISA in the US, and also the Canadian government cyber council, probably among others, of 3 CVEs that affect Cisco ASAs and firepower threat defense devices. Details are a little bit sort of scant at the moment, but they've been disclosed as under active exploitation, and as with Palo Alto, having been used to drop backdoors on systems. The bit that's, I guess, less clear to me is exactly how the initial exploitation happens in this case. So for the Palo Alto, there's a great write-up, I'm sure we can put the link in the usual places, by Watchtower, actually reverse engineering the vulnerability to understand how it happened. With these 3 Cisco CVEs, 1 unauthenticated denial of service, 2 authenticated RCEs, it's not really clear how we go from these 3 CVEs to there's a backdoor on the device, but that is what people are, everybody is saying has happened.
It's interesting that the denial of service CV has a higher CVSS base score of 8.6 than the RCEs, which is really interesting. Because to me, an RCE, especially unauthenticated, which I think it is, Aaron, keep me honest here, I'm not sure if they are unauthenticated, but certainly anytime it's an arbitrary code, that's kind of game over in my book.
Yeah, actually they are authenticated. I had to double check that one. I thought one was unauthenticated, which made the whole thing make much more sense, because these were allegedly used to drop backdoors on systems. So an unauthenticated RCE was like, well, obviously that's how it's happening. But if they're both authenticated, that implies that either the attacker has stolen credentials, or there is another vulnerability that lets you get to the authenticated RCE by bypassing auth. And if that exists, we haven't seen it, or it's not been linked to these 3 yet.
Yeah, I mean, certainly having it as an authenticated RCE certainly sounds like it's a much higher barrier to kind of entry. But how many ways are there of like you said, other kind of bypassing authentication protocols, stealing credentials from elsewhere, tokens? So I really wonder how much of a barrier it really is that they need to be authenticated. And if nothing else, it just needs a malicious insider to conduct the attack.
Yeah, and we see, as I'm sure you guys do in labs, an awful lot of information and data around stolen credentials.
Yeah.
Right?
Yes.
So yeah, it only takes 1 weak password, or 1 brute forcible password, or 1 stolen password set of credentials, and an authenticated RCE, if it's exposed to the internet, very quickly becomes, it might as well be unauthenticated.
Yep.
So this one got me thinking a little bit about something maybe a little bit more general again. We don't have a whole lot of details about how these particular exploits work. I mean, we have some, but not a great deal. And there's a tension there between how much a vendor wants to say about how a particular vulnerability works, which they're going to be necessarily somewhat cagey about because they don't want to make it easy for people to reproduce or create an exploit. But we end up getting a lot of information about what people who are actually already exploiting it are doing, but not necessarily how they're getting that initial access. Which makes sense from the perspective of a corporate threat hunter in the sense that, like, oh, okay, well, this is something that maybe we've already gotten attacked by, possibly successfully. What are the typical TTPs that we're seeing, or what are the hashes, or what are the backdoors that are being dropped, or any of this kind of stuff is very, very useful from that perspective. I kind of wonder though, is there a better way to disclose information that would allow people who want to set up defenses at the edge against the initial exploit without maybe telling everybody how to do it?
It's a really difficult ongoing kind of conversation, if not argument, isn't it, in the security community? How do you have responsible and efficient kind of disclosure? Because I mean, Malcolm, we were talking offline, weren't we, about the kind of sensor networks, and quite often that you will see, the sensor networks generally pick up the kind of broad sweeping kind of constant scan of attacks and traffic on the internet. But it's typically after proof of concept code has kind of been released, because then it's a piece of cake, to just kind of copy and paste from or clone a GitHub, and then anyone can run it, or even clone a container. So zero effort. So it's a really unfortunate truth that, the more information up front would absolutely kind of help us all, blue teamers in particular. But it's then available to everyone, and it just then makes attacks so much easier for everyone to conduct.
Yeah.
It's a question we see a lot in the F5 cert through support cases is, are the WAF signatures for? And the question is always, are there WAF signatures for, and then some initial exploitation vector? And very often there aren't signatures because there is no POC, because vendors like F5 don't like to release details of how to exploit the vulnerability, because it gives a leg up to the attackers. And we've already seen patches reverse engineered pretty quickly, but if a POC is out there, then widespread exploitation happens in a matter of hours. So there's no perfect answer to that.
No, there really isn't.
All right, moving on quickly let's quickly talk about some processor stuff. So we've talked about Spectre and Meltdown and processor vulnerabilities a number of times. We talked about them in last month as well. This month saw patches for native branch history injection vulnerabilities hit the Linux kernel. And that goes back to Spectre v2, which was previously thought to be pretty difficult to exploit until some researchers, actually we talked about them last month, VUSEC, created a tool called Inspector Gadget, which has a hilarious name. And they discovered 1,500 Spectre gadgets and 2,100 dispatch gadgets that make practical exploitation significantly more likely. I think, I read about this briefly, but Malcolm, I think you read a little more than me, maybe, on Inspector Gadget itself specifically.
Yeah, a little bit. I was very interested in the way that the researchers used a technique called symbolic execution to find all of these gadgets. So they knew what they wanted to do. They knew how the conditions that they wanted to find, and that's a perfect situation to use symbolic execution, which really briefly is a means by which it's a little hard to explain, but consider you have a branch, right? So you have a variable, and say like the variable is X. And if X equals 5, you go down one branch. If it's anything other than 5, you go down the other branch, right? Well, so symbolic execution is a means by which you actually don't say X is equal to 5. You say X is equal to a symbolic constant. And you can manage, and this is all done kind of in an emulation sort of context. It allows you to be able to very easily pick and analyze all the branches. So you can bring yourself to whatever part of the program you're the most interested in, and you can determine what the constraints are to reach that part of the program, right? This is a super effective technique to, if you, for example, know that there's a bug in a particular section of code, and I'm not talking about processor code here necessarily, but like just in general, binary exploitation, this is a great technique to be able to figure out exactly what state you need to get a program into to be able to exploit that bug. They applied this to finding the right combination of instructions and data and so forth to be able to set themselves up to get to the point where they could generate the conditions where they could do a Spectre V2 attack, right? That's my understanding anyways. So really, really great work. I thought it was a marvelous application of that. And I think it goes in general to say, whenever you have a deeply complex bug, and people say, well, it's theoretically possible to execute this, my bet is always on it's not theoretical. It's just no one's quite done the work yet to figure out how to do it reliably. But eventually somebody will.
Yeah, absolutely. 100% with you on that. That's, it's a given that sooner or later someone will put in the work. I was going to use an analogy that I guess could be slightly political, but it becomes hard. Let's say it becomes very hard to extract oil from a well, so it's cheaper to go extract it from a different well. But if the cost of materials goes up far enough, now it's cost effective to go back to the first well. Well, sooner or later it becomes cost effective. You've closed all of the other holes. It becomes cost effective to come back to this one and put some more time into it. Find a way to practically exploit it. I think that's something we should be very wary of. All right, before we move on to the last thing, I'll just call out that after 48 years, a processor that's very close to my heart has been discontinued, the Z80. There's one right behind my head for those watching in video, and just over my shoulder on the other side. It's a sad time indeed. With none of these speculative execution problems back then. We had 8 bits and we were happy for it.
Right.
And precisely one execution pipeline. Speaking of pipelines, HTTP2. Yeah, it's a good segue, that one.
Very nice.
HTTP2 was in the news recently because of a new attack vector called the continuation frames attack, or names thereof. And I thought we should talk about that a little bit. I don't know if
this
David,
kind of
you read
caught
about
me
this?
by surprise a little bit. I've had to be reading up a little bit because initially kind of saw the headlines HTTP2 DOS yet again. I thought, well, it's just rapid reset. It's kind of rehash, but it sounds very different from what I understand. Rapid reset was something that discovered, I think, October last year, October 2023, rapidly became the kind of cause of some of the biggest DDoS attacks that the world has kind of seen. Hundreds of millions of requests per second. I think quite interesting as well. You kind of talk about those kind of numbers, and they sound, it's volumetric. It sounds like it's filling up your network connection, but it's very much an application attack, from what I understand. The rapid reset, it's consuming CPU cycles, it's filling memory on the kind of service. So very much kind of app layer. But continuation frames is the same but different. It's another DDoS attack, right? Still HTTP2, but it's something different altogether.
It is the same but different. Yeah. Aubrey, if you're there in the background, actually, if you bring up the slides that I've got, I just have a couple of slides. So the rapid reset attack that you mentioned looked like this. Rapid reset is on the right there. And it was a way in which you could deny service to clients by making sure that all of the HTTP2 worker threads, typically servers have, a thread per client, more or less, were busy, always busy. And you did that by exploiting the protocol such that you could send lots of requests and then it basically immediately say, forget that request. I didn't mean to send that, and then send another one. So you had this graph, and it consumed very little bandwidth on the client side because these are just small, very small frames. But you could consume a lot of resources on the server side. Different to a classic HTTP1 or HTTP2 volumetric attack, where you need lots of resources on the client side as well to receive the responses, as well as potentially send not large, but requests that are, a number of bytes. They aren't very, very small. So if we want to talk about what the continuation frames attack is, we'll just quickly talk about the differences between HTTP 1.1 and HTTP 2. So 1.1, probably everybody knows, it's a text-based protocol. The server and the client basically have to receive every character and then pass every character individually to understand what part of the message this is. That's what gives us HTTP smuggling attacks. So it's, every line ends with the carriage return line feed. That denotes the end of one line and the start of the next. Headers end with a colon, and then the header content, and then CRLF denotes the end of that header, and so on. And HTTP 1.1, if we ignore pipelining for a minute, is essentially request response. It's an entirely linear process. If you wanted to send many requests at once, you need to open many TCP connections. It's not the fastest. So HTTP 2 is designed to make this all much more efficient. And it's all about gaining efficiencies in processing. So it introduces a number of concepts. One of those is streams. So this is all one TCP connection, everything on this slide. But there can be multiple streams within that single TCP connection. So we get away from the three-way handshake overhead. Within those streams, the requests and responses, HTTP2 is a binary protocol. So we don't have to pass character by character anymore. There are well understood delineations for where data starts and ends. And servers can do away with that processing overhead. And we lose some of the smuggling vectors. Some smuggling vectors have still been demonstrated, but for the purposes of this, let's pretend those don't exist. So we gain a bunch of efficiencies, although realistically, it all boils down to the same kind of thing. We're still sending, I'm sending a get method. I want this page. This is the version of the protocol that I talk. These are all headers, and they're inside my request. These are like logical containers within HTTP2. And then the response, and here are the headers for the response. They look a lot like HTTP 1.1. The difference is here that this is an entirely asynchronous process. So as a client, I can send 100 requests, and no longer do I have to remember the order I sent them in, because the responses will come back in the same order. Requests and responses can fly off in any order. And because this is, the requests are within a stream, I always know where to associate the response back to, and I can even do things like prefetch data and so on. So headers aren't the only kind of frame in HTTP2. Obviously, we need to send more than just that information. So there's a bunch of frame types. Data, headers that we've already seen, priority. Reset stream, that's the rapid reset attack. Settings so that the client and server can agree on things like how many streams should we both support. Push promise, just briefly, HTTP2 supports pushing responses to the client before the client has ever asked for them. If as the server, you know the web browser is going to need certain resources to render a page, you can just proactively send them. Go away, you can see here, that's like an HTTP2 sort of, you've done something wrong kind of message, because
This is my favorite frame tag, I've got to say.
Save the go away. It's part of the HTTP2 flow control, because within essentially within TCP, you have HTTP2, and within the HTTP2, you've got your own flow control outside of TCP's layer. And then continuation, we can see there. So continuation is used, like what if you want to send lots of headers and maybe the client doesn't have all of the headers right now? It needs to kind of do some thinking before it has the rest of the headers. So you can split the request up into multiple frames. Let's say you have a headers frame. You can follow that with one or more continuation frames with the rest of the headers in. An obvious example might be cookies, right? Because you can have a lot of cookies to store state in HTTP. That works the same way in HTTP2. And so maybe you need lots and lots of these frames to send lots of headers. And on the last continuation frame, you set a flag, end _ headers. Right? It says, I'm done sending headers.
Would another situation possibly be if you were, like, say, uploading a file? Like you're saying, a post or a push, and you have a lot of data, so you might be chunking it up into
sending chunks of data. Yeah. Although at least I believe continuation frames only contain headers, not payload.
Only for headers. Okay, thanks.
Yeah. You can send, and the RFC says you can send any number of them as long as the last frame was either a continuation or a header frame, and as long as you haven't already sent a continuation frame with the end headers flag. So by design, the designers of the protocol, like, we might need to send lots and lots of headers, so we'll accommodate that. And we don't know how many headers the future web might need, so we'll say any number of them. Unfortunately, that's exactly where this attack comes in. This attack, if anybody remembers Slow Loris in HTTP 1, is very much like Slow Loris, but for HTTP 2. And you just never stop sending headers. Right? That's basically what the attacker has to do, is just never stop sending headers.
This sounds like a really kind of unidirectional kind of or unbalanced attack, in the sense that, similarly to kind of rapid reset, you don't need a lot of resources client side. You don't need a massive botnet potentially to do this. Actually, because of the HTTP2 protocol, you can do this from a single machine or a very limited number of kind of client side attacking resources. Is that right?
Yeah, exactly. And so one of the things about rapid reset was some of the protection mechanisms for that were to prevent clients from instantiating many streams without any of those streams having had a response, right? So that was the sort of protection for, you can't send 1,000 requests and 1,000 reset streams, because when you send the 100th, I know you're probably not a legitimate client, and I'll make you go away.
Yep.
So you could pivot to this attack, where you could open 100 streams per TCP connection or per, bot in a botnet. And down those 100 streams, you only need to periodically send a very small amount of data. So it's still quite unidirectional. There's no response coming back. You don't need to sync all of that HTML someplace or have the bandwidth to consume it. But you can also do this attack over a longer period of time. Relatively speaking, you still want to send them quite quickly, but not as fast as they were in the rapid reset attack. And you can consume either memory or CPU on the target devices. There's, if people Google for Vince VU421644, that's what the technique was disclosed under, to 100+ vendors, including F5, for those vendors to go and look at their products to see if they're vulnerable. Some products were vulnerable in that it drove up memory utilization, because the server is essentially trying to build a structure in memory that contains all of this header data. And every time a continuation frame comes along, it's like, oh, I better glue another structure on the end, and you run out of memory. Other servers, the researcher, it's a guy called Bartek, who is a pen tester and has a pen testing magazine as well that you can subscribe to, discovered that if you compress the headers, so HTTP2 supports compression of basically every artifact using HPAC. HPAC compress the headers, and some server software will run out of CPU because it's getting an endless stream of compressed information that it's having to uncompress before it can do anything with. Those systems don't run out of memory, they run out of CPU first.
Right. So are these, I mean, both with rapid reset, but specifically with the continuation frame issue, it sounds like it's not an implementation problem. It's like, it's not a CVE, it's not a problem with the implementation, it's actually a problem with the protocol itself. Or rather an exploitation of like the way it was, designed on purpose, effectively.
Yeah, that's exactly what this is. At least in my opinion, everybody was following the RFC to the letter. I must accept any number of continuation frames, and the RFC probably should have put some realistic limits and bounds around the number of continuation frames that you could send, or the behavior of the reset for rapid reset. But the RFC was written to try and encompass all possible situations, and so it was written in an open-ended manner. And so while there are some CVEs for the HTTP2 continuation frames attack, they are those CVEs describe the specific, if you like, the specific way that specific piece of server software is impacted by this traffic. It's valid traffic. It's valid for the RFC, and the servers were implemented the RFC right. Nobody got it wrong, but inherently the RFC allowed this attack and rapid reset.
So is the general approach to kind of mitigate this, is it vendor software based kind of patching? Is it just kind of some kind of rate limiting? Is it a case of having to go back and rewrite the protocol essentially as well?
So, I mean, I would say that the RFC could maybe do with some tweaking there. Some implementations are robust. So Big IP and Nginx are robust to this attack in Big IP's case, because we do actually apply a limit to the amount of headers that you can send on an HTTP connection, whether that's 1 or 2. So when you reach that limit, we will send an HTTP to go away, and we will terminate the client. So that also means that if you have a vulnerable, say, Apache, or what else was vulnerable, Envoy, GoNet HTTP server behind the Big IP, we effectively protect that target system. Nginx, similarly robust, as long as you've done sort of basic denial of service tuning of the config, which you would do for HTTP 1.1 or 2 alike. It's robust because the connections can only live for a certain amount of time without having received the entire request, which should sound very familiar because that's the protection for slow Loris.
Yep.
And many other implementations were similarly robust. There were, I think, I want to say 7 CVEs, but it did change as this was, let's see, 1, 2, 3, 4, 5, 7, 8, 9 CVEs.
Yeah, we get that occasionally. It was in the CV landscape, or the evolving CV landscape report we had a year or so ago, where actually like the one kind of vulnerability or the one issue had hundreds of CVs attached to it, because it was just CVs attached to a vendor and a specific bit of software. So like you said, sometimes you can get the one issue that can result in tens, dozens, even hundreds of separate CVs that are all effectively the same thing.
Yeah. In this case, 9. It was, I think, 6 up until a day before it was disclosed, and then 3 more were found to be vulnerable, and some more will probably, there's a good chance that more will pop out as time goes on, right? As people dive further into this or do similar research. Quick is a very similar protocol, shall we say? So it wouldn't surprise me if some of the same problems are going to exist there. We just haven't looked at them yet.
Yep. Well, I need to go and find myself an HTTP2 Go Away t-shirt, because that just sounds like the perfect kind of thing to have plastered across my chest.
So I talked at length about that. David, Malcolm, anything from labs that you'd like to tease?
Yeah, there is one thing I will kind of share with everyone. Actually, we're kind of heads down finishing up some research and reports. But the one to kind of tease, one thing to tease with everyone is that we're all going to be at the RSA conference in San Francisco in a month. Myself and Sander are going to be presenting on stage. I think session is called, what's the session code? I can't find it. It's Thursday morning. It's 10 to 11 in Moscone West. So we're really looking forward to that. The session is going to be covering the identity threat report that was published at the end of last year. For anyone that hasn't kind of seen the report or kind of read it, actually, Sander in particular, I mean, being the original kind of author and researcher on it, goes into so much kind of detail and does an awesome job at kind of explaining the context and relevance in terms of why the automation is such a big problem in terms of credential stuffing and the threat that poses. So that's the thing for that's going to be occupying us for the majority of kind of May with the travel. So if anyone is out there at RSA, please come along, join the session, or come and say hi afterwards.
Cool. Thanks, David. Hope you enjoy RSA.
Thanks.
On that note, I think we are over time for the news segment, so we better bring Aubrey back before the timer expires.
Rescue us, Aubrey.
Yeah.
Hey. No, great segment as always, guys. Actually, I'm going to go ahead and clip that HTTP2 segment out for community video. I think that's something that is fascinating. And of course, if there's something out there that's like Sloloris, we should all, as practitioners, understand what that's about. So there will be more to come on that. Okay, well, I got one last thing I promised. We're going to talk to Pete, right? So I had a chance to catch up with Peter Silva not too long ago and explore some of what he's been working on over at a division of Ericsson, who is now in partnership with F5 openly, which is fantastic. We had a ton to talk about, and I'm just going to give you kind of the basics before we wrap it up for the week. So without further ado, Pete Silva.
Fascinating stuff. Did you see the story recently of Ray Systems? So it just came out, right?
Yeah.
So it was reported back, I think the first, report was September, November. And for those of you who don't know, it's any scales Ray Systems. And this is pretty much the bona fide AI ML framework for Uber,
Scale.
Netflix, ChatGPT, handling the AI and ML traffic. Well, they had an open API. This API was the jobs API, not careers as most of us think when we hear jobs, but it's creating these AI and ML jobs. Now there's a dispute. So there were like 5 CVEs in this. 4 of them they fixed, but there's this 5th CE, which is the no authentication access for this, which allows, attackers to go in and create jobs, delete jobs, grab sensitive info. And, there's researchers out there who have the screenshots of the, admin login, IP address, blah, blah, blah. So they're disputing it. Then this kind of goes to an area that I've been playing in, isolation. And they're saying, we disagree. Now, in their this upcoming release, they're going to add the option to, enforce a password to gain access. But they were saying, no, this is actually that's a vulnerability. That's a bug. And they're like, no, it's a feature. It's a freaking feature. Do you want to know why it's a feature? Is because it needs to be in an isolated environment. It needs to be an isolated network. We tell you, do not allow this thing to be internet accessible. Do not allow untrusted devices to gain access to this. And it's being reported as the first known in the wild attack on an AI workloads.
Yeah.
Fascinating.
Yeah, I thought it was amazing too, because all the headlines on that said, there's no fix for this, and it's funny, there are so many AI features that there is no fix for, and they are flawed because they're flawed. They have to be flawed because we expect them to do things for us, like go out and search a website and then try and make something out of what they find at that website or whatever. You don't want to patch that. We want them to do that.
Exactly.
And of course there are going to be mistakes and things, but it's funny, the way you describe that in an isolated environment, it reminds me of the same thing my routing engineers used to say back in like circa late 90s about TFTP.
Yeah.
You need TFTP to be able to have routers communicate with stuff back in the day. But you didn't do that on the open internet, or you were owned, right? That is right. As somebody who has been, unfortunately, victim to a TFTP attack way back in the day, I can attest to that. So, last thing I want to mention, of course, thank you for tuning in. It's always great to hear from our guests as well as our usual panelists. Coming up this month, some of you may have noticed my choice of clothing. That's right, I am wearing an AppC University sweatshirt. So, coming up May, I believe it's the 22nd, I will be speaking at AppC U's AppC Con. So if you are interested in finding out a little bit about the Iron Man method for API security with artificial intelligence, you are going to want to definitely tune into that. And there are still lots of seats available, I'm sure. Hope to see you there. And with that, I'm going to call it quits for the month. Thanks for tuning in for our name change episode, and we hope to see you again next month for AppC Monthly. Thanks for checking out AppC Monthly. We hope you enjoyed it, and if you did, please let somebody know. Click that like button and hit subscribe to stay up to date on all the latest in the AppC world between now and the next episode of AppC Monthly.